Hello everybody, my name is Hadwin Link, and today we are going to be going over VEX sensors and their functionality. So some important information to go over before we start is that the PROS API is currently on 4.2.1, but the finished documentation is only 3.8.0. There is 4.0 documentation, but it is in beta right now. 3.8.0 documentation is still usable in most cases, but some new functionality might just be gone, and variable names might be changed. I'm only going to go over what I think are the most important functions for each part. If you want to see all the functions that there are, check the documentation, but for the most part, the ones I go over are the ones you're going to be using. First off, we have the inertial sensor, which can be defined with PROS IMU. This sensor tracks the rotation of the robot or part it is on. Some methods it can use are reset, which calibrates the IMU and takes about 2 seconds to do, get heading, which gets the relative position from the start or calibration bounded from 0 to 360, and get rotation, which gets the unbounded rotation from the start or calibration. If it's clockwise, the number is positive, and if it's counterclockwise, the number is negative. This is very useful for simplifying rotation odometry, so you don't have to do a whole bunch of trig with rotation sensors. You just need to add it on, and you'll get the numbers you want. The next sensor is the optical sensor, which can be defined with PROS optical. This sensor detects color, proximity, ambient light, as well as hand gestures, such as waving up, down, left, or right. Some methods that it can use are enable and disable gesture, which toggles gesture functionality. That's important to know because if you turn on gesture functionality, you won't be able to get the hue, saturation, brightness, or proximity from the sensor. Get gesture gets recent gesture data. This is cleared after 50 milliseconds. Get hue, get saturation, get brightness, get proximity, and get RGB are all self-explanatory. The gesture functionality is good for something like an auton switcher, and getting hue and RGB and all those other things is pretty good for something like color sorting different field elements. The distance sensor can be defined with PROS distance. This part measures distance from 20 millimeters to 2000 millimeters, or 2 meters, and can also return object size or velocity. Some methods it can use are get, which gets the current measured distance in millimeters, get confidence, which gets how confident the reading is from 0 to 63, 63 being high confidence. Keep in mind that this part only works past 200 millimeters because anything closer will be very confident. Get object size gives the current guess at the object size from 0 to 400. There aren't any units here, it's kind of weird how they set that up. And get object velocity gets the object velocity in meters per second. The accuracy of this part varies, as both getting the object size and the confidence are based on guesses, but it's still pretty useful. The rotation sensor can be defined with PROS rotation, and it can measure the rotational position of an axle. Some methods it can use are reset, which resets the absolute position to the current rotation it's at, set reversed, which changes which direction is forward for the sensor, which can be useful if you have to put it on at a weird angle, get position, which gives the rotation in centidegrees, which means you have to divide by 100 to get degrees. This is unbounded. Get angle gives the unbounded rotation from 0 to 36,000 centidegrees. And get velocity, which gives the axle's velocity in centidegrees per second. This is one of the most useful sensors in the entire catalog because it's very useful for odometry along with the inertial sensor. The optical shaft encoder can be defined with PROS ADI analog in. It's yet another way to measure shaft rotation and can be used with the default methods for analog in, which are calibrate and get value. This part has less functionality than rotation sensors, but the smaller size might mean it's easier to add in certain cases if you're running low on space. The potentiometer can be defined with PROS ADI potentiometer and measures the angular rotation of a shaft. Potentiometers have one unique method called get angle, but other than that it's the same as ADI analog in. It's a very niche part. I've never really seen it used, but it can be used as another way to check the angle of a part. The GPS sensor can be defined with PROS GPS. This part easily tracks position of the robot based on the pattern on the walls of the field, as you can see down below. Some methods you can use with it are initialize full, which sets the initial position in GPS offset, get position and orientation, which gets the position on the X and Y coordinates, roll, yaw, and the pitch of the GPS, rotation and position data basically. There are also functions to get all of these things individually, which is useful if you only want to get one of those things at a time. One of these functions is get heading, which gets the rotation from 0 to 360 degrees. This can serve as an easy way to track position, but doesn't work off field or on older fields that don't actually have the patterns on the field. In most competitions, you are going to have these patterns on the walls, but it's something to keep in mind when you're designing your robot. There are a few ways to handle odometry. We've gone over some of the sensors that can be used for this just now, and odometry is very useful. A lot of the sensors you're going to be using are going to be for odometry if you want to make a high-level Auton script that can make really precise movements and consistent movements. There are a few ways to do Auton. The one I prefer is rotation sensors in IMU. This requires a lot of setup through both programming and building. You need to build the robot explicitly for odometry. You can see a picture of some of the things that you might need for an odometry script on the side, and also a link that I'll add in the description for some resources on how to do the math behind it. This setup is important because if you actually get it to work, it's much more consistent than most other options that you have. The GPS sensor is a way of doing odometry that is much less setup, but it's also dependent on the robot being able to see the pattern on the walls or the pattern on the walls being there. So if you're trying to test it, but your home field doesn't actually have patterns on the walls, this is not really going to be the best option. The next sensor we have is the light sensor, which is defined with PROS ADI analog in, and it senses brightness from 100% to 0% illumination. Some methods it can use are calibrate, get value, and get value calibrated, which do the same things as any other ADI analog in. ADI analog in is a generic type that can be used for a ton of different sensors regardless of what they actually end up doing. This is the same with ADI analog out, ADI digital in, and out as well. This is one of the more niche sensors, but still might be useful in some situations where you want to detect light values in a room or something. I don't personally think it's that useful for something like Vex Robotics Competition, but you might find a use for it. Next part we have is the bumper switch, which can be defined with PROS ADI digital in. This part acts like a button, and some methods you can use for it are get new press and get value, as expected of a button. This part can be used to detect collisions or as a button for an Auton switcher or other program function selector. This is very similar to the limit switch, which also acts like a button and can be used in the same way with the same methods. It has a different angle than bumper switches though, and can be used for detecting specific robot part angles to trigger some behavior. Next part we have is the line tracker, which can be defined with PROS ADI analog in. This part detects brightness of the material it is pointed at in percentages. Some methods it can use are calibrate, get value, and get value calibrated. This part is pretty useful for following lines on the field if you're going that direction and trying to avoid odometry, because there is reflective tape on the field. There's one part that I haven't mentioned in this video, and that is the AI vision sensor. This is one of the most complicated parts Vex actually sells. There's a lot of methods and terminology that it uses that I couldn't really explain particularly well. I would recommend reading the documentation if you're going to use this part. That's all for this video. This has been Hadwin Link, and I will see you in the next one.